actually 10% of GDP relies on the satellite navigation, which is a really interesting number.
Welcome to another episode of the MapScaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Wojciech Ford, and apart from being yet another victim of my terrible pronunciation, Wojciech also works with innovation and market development at the European GNSS Agency. So Wojciech has a ton of experience of working with innovation, and especially innovation based around the global navigation satellite systems, and he's agreed to come on the podcast today and share some of his insights and experience with us. So the hope is, of course, that this will help you with the things that you're working on, and I think this will be especially applicable if you're working on a project with the hopes of commercializing it. Just a quick heads up before we start today. A couple of times during the episode we mentioned the Galileo and EGNOS, and just in case you're unfamiliar with those two projects or systems, Galileo is a GNSS, so a global navigation satellite system. You might be familiar with a similar system that's called GPS. And EGNOS. EGNOS stands for European Geostationary Navigation Overlay Service. So this is Europe's regional satellite-based augmentation system, or SBAS. So I haven't published an episode about EGNOS specifically, but we have covered SBAS systems before, and if you're interested in learning more about those, I'll put a link to that in the show notes. So that's it from me. I'll be back at the end of this conversation with just a few things that I would really like to highlight for you. Hi Wojciech, welcome to the podcast. Thanks very much for doing this with me. So just so the listeners know, you are the Innovation Officer in the Market Development Department of the European GNSS Agency.
Exactly.
That's the second time I've tried to get that out, so I'm pleased that it worked that time. Before we start, could you just tell me a little bit about your job? What do you do, and who do you do it for?
Sure. So as you said, I'm working in market development, and specifically I work in the area of research and development. We are trying to support the companies implementing the solutions based on our satellite navigation, and we do it via different ways. So with grants such as Horizon 2020 and Horizon Europe, then competitions supporting innovative startups and individuals, also the private investment to support them further on their journey to deliver a product or service on the market.
I think perhaps we jumped in a little bit deep there. Would you mind just describing for the listeners what the European GNSS Agency does, and a little bit about those services that you were talking about just before?
Yes, so in GSA, we are a gatekeeper of the security of the two systems, which is Galileo, that is the global navigation satellite system, and EGNOS, which is the augmentation system localized for Europe. And as I said, we are gateway of security accreditation. We are operating these two systems. We also taking care of market development of the satellite navigation in Europe and market uptake of these two systems.
So you're working with people and companies that are building these innovative products around global navigation satellite systems, positioning systems. Can you give me an idea of what kind of industries that these products are aimed at, or where you see this innovation happening?
Yes, maybe first I want to mention, that one thing is to build the satellite system. So we invested in Galileo and EGNOS, but without the final users, it will be basically just a piece of hardware orbiting the planet and sending a signal in space. So what we want to do is we want to make sure that it is being used by people. And there is actually value chain in different market segments, how it can get to the final user. And actually the applications of the satellite systems are endless, and we separate them into different market segments. So for example, agriculture, location-based services, which means mainly phones, transport usages, that is navigation and maritime. In aviation, the landing procedures are using EGNOS a lot. Typical, of course, is navigation on road, but also rail. Then geomatics, a market segment, They're usually the first adopters because they need the highest precision. And last but not least, timing and synchronization, because Galileo is not only about positioning and navigation, but also about timing. And a lot of people don't know that you can get exact timing from the system.
When somebody comes to you with an idea, so the idea, of course, has to use the global positioning system, the GNSS system in some way, shape, or form. How important is like the hardware, the technology, the addressable market, and how important is the team or the person behind the idea?
Yes, that's actually a good question. Thank you for that. And I think partially the reply is all of it, what you mentioned. Actually, 10% of GDP relies on the satellite navigation, which is a really interesting number. It depends on the level where the company is. So in terms of private investment, the team is very important. So when you start up and you form a team, what the investors are usually looking at is that you have good composition of people in the team which have their field of specialization. When we're speaking about bigger projects, grants projects running within the programs such as Horizon 2020 and Horizon Europe, there we're speaking about consortia of companies. So they usually form of, let's say, bigger group of companies which are working together on the project. And there it's also important that each of them brings something to the project. So one company can bring the knowledge about satellite navigation. Then you have another company representing the end users, for example, which are defining the user requirements. Then you have companies which can provide additional technologies or can help with the business process of the project.
Thank you very much for that. So I know that you work on a number of projects at any one time, but in a previous conversation, you gave these two really great examples, and I'm hoping that you could take the time to walk us through those. Perhaps we could start with the drone example after earthquakes or landslides or building collapses. Do you mind repeating that example for the listeners and walking us through that?
Yeah, sure. So this project is called MobNet. Full name is Mobile Network for People's Location, Natural and Man-Made Disaster. It's an older one, but it's my favorite. And the problem they're solving is that they're trying to locate victims during natural disasters and situations of emergency, such as earthquakes, hurricanes, or large snowstorms. And how they do this is thanks to the mobile phone, because they found out that most people that you find in debris after an earthquake, they still have mobile phone with them. So they actually, instead of the person, they're searching for the mobile phone. And they do it with a drone. So drone, which has on board precise Galileo and EGNOS receiver and digital stereo technology module, which can behave as a cell tower for GSM. And this drone can fly over the area where they're searching for the victims. Because it acts as a tower, the phone tries to connect to the drone. What it does is that it's measuring the time of arrival of the signal, so it can calculate the distance at the time to the mobile phone. And then the drone flies in multiple locations and connects with the phone more times. Like this, it has more distances from the known positions because it has GNSS receiver on board. So what it does is the process called trilateration, which is at the end the same process which the GNSS is based on. That means that from the known distances from the known points, it calculates the final position of the mobile phone.
So that sounds like an amazing use case. I've got a couple of questions though. Like it seems to me that perhaps the telecommunication companies, they could speed up the process. Why can't I go to them after a disaster with some sort of bounding box, geographic area and say, please, can you tell me all the locations of the cell phones that are in this area? Wouldn't that be a faster way of doing things?
That's a good question. But first, I would say that the precision is not sufficient because the requirement of the civil authority in that project was to have 2 to 5 meters in the search and rescue applications. And you cannot achieve that with nowadays network. And secondly, and maybe more importantly, usually when you have an earthquake, the network is down. So often it happens that it's not functioning because of the earthquake.
So you mentioned that part of the magic here is the drone has a GNSS chip on board, so it can understand its own positioning in terms of the rest of the world. But you also mentioned Galileo and EGNOS. So those are European systems. With the same system, with the same technology, the same idea, will that work in other places in the world as well?
Yes. So it would work because Galileo is a global system and EGNOS, as you rightly pointed out, is local system for Europe. But the solution would work anywhere because EGNOS is just an additional feature, additional measurement of the system. So actually the system can choose from the available signals to always provide the best precision. But when it doesn't have the EGNOS signal, it can still work quite well. And EGNOS is just an improvement.
What about in terms of that spoofing of the cell phone tower? So we have this piece of electronic on the drone that is pretending to be our cell phone tower. Would that also work in different geographic locations, or is this local to Europe?
So it is true that different geographical locations are working on different frequencies. However, this is solved because the devices can work with these multiple frequencies already. So typically when you have a mobile phone, it is already equipped with hardware which can work on multiple frequencies, because then when it is shipped to Europe or United States, it still works because it is compatible with both. So the system can be developed also to be ready for multiple locations. And you also mentioned kind of spoofing of the signal. And it is true that in many countries, it is actually illegal to kind of have a device which acts as a cell tower. And because of that, the project had to do the testing after special agreement in a military field. So it was done under these conditions. But also the civil protection forces, which would be using the system, they can get approval for usage of such a system in emergency situations.
And what does the output of this look like? Do I have several drones flying around, and then the output is some sort of map with locations on it, or is it something else?
Yes, so the user has a base station with a map, and they get the coordinates and the position of the victim on the map.
Can you give me an idea of some of the accuracies we might be able to expect from a system like this?
Yes, so in the white area, the user requirement was to have a precision of 10 meters. And in the urban area for a search and rescue application, it was 2 to 5 meters. And the project achieved this 5 meters accuracy.
Wow. This is incredible. This could save a lot of lives. When can we expect to see systems like this in operation?
Well, I hope as soon as possible. This project, I have to say, is older, and this is one of the projects that have not made it to the market yet. This is also the reason why we're looking how to develop such ideas further. Because, one thing is that you're developing a product which will be commercial and the company can make a profit on that. But then there are also another ideas and technological solutions which are saving lives. I think it is worth to support them and pursue these kind of ideas. So now what we do is we're looking how to support the consortia and companies further even after they finish such a project.
What do you think they're missing? Like, it seems like a great idea. It's going to save lives. It's going to have a big impact on people. We're constantly thinking about the increasing level of risk with things like global warming, and the world is changing. We're occupying more and more space on the planet. Like, what's missing here in this equation? Why hasn't it been implemented in the market already?
It is because the solution is not final product. So we're usually measuring how ready the technology or the solution is via so-called technological readiness level from 1 to 9, where the 9 is the final product. And this project specifically, they developed the prototype on TRL7. So they would still need investment to arrive from TRL7 to TRL9, which is the final product. So they would need to find a partner which is able to industrialize the product and then sell it. And what sometimes also happens is that these people behind the project, they're very good researcher, they're very tech savvy, but sometimes they're missing this business approach and knowledge of the market. And this is also the reason why what we do in these projects, that we also give them business expert, which is advising them on the business plan, how to execute it and how to arrive to the market.
Thank you very much for walking us through that example there of finding people after a natural disaster using drones. Really appreciate it. Perhaps it's time to move on to the next example that we talked about in an earlier conversation, and that was the positioning of firefighters indoors. Would you mind walking us through that one?
Yes, it is actually also my favorite project. Actually, behind this proposal is one of the firefighter brigade that later on became part of the project. It happened to them that they were extinguishing fire in one of the buildings, and the building collapsed. And then they were trying to find the firefighters which were in the building, but they didn't have clue where they could be because they didn't have any positioning system, any reference where the firefighter is. So it took them a lot of time to find them. And they would need a solution in such a situations when the things go wrong, that they can locate the firefighter and rescue him. And the second problem is that often the commander knows where the problem is, but the commander doesn't know exactly where the firefighter is. Some, like, they have voice communication, but not always they can tell where exactly they are. So this is the second reason why they came up with the requirements that they would need location of the firefighters, which can be displayed to the commander during their work.
Okay, so the problem they're trying to solve, just so I understand this, the problem they're trying to solve here is that we're trying to locate firefighters indoors during an active fire, and we're trying to show the manager of the situation where those firefighters are, because that person can communicate with the firefighters. They can say, hey, please stay away from this area. That's a dangerous place to be, if they know where the firefighters are. Is that correct?
Yes, that is correct. Of course, this can be done easily with GNSS when the firefighter is outside. So when you have some fire on the field, you just arrive and they have good visibility to the satellites. However, the conditions are not always so ideal. So sometimes they go to the forest where they have a little bit worse visibility to the satellites. And sometimes, as you mentioned, they go even indoors in the buildings where the signal from the navigation satellites is completely blocked, and they need to rely on different technology. So in case there would be such a solution which can help them navigate, it would literally save lives, because when firefighters can work safer, they can also save more lives.
So what is the solution? Now that we understand the problem, what is the solution?
Yes, so the approach, how the project solved this problem, is taking into account three technologies for positioning. So the first one is, of course, GNSS, multi-constellation. So they're using Galileo and also EGNOS for the positioning, for the absolute positioning. And this is the primary source. Then they're using ultra-wideband to measure the distances in between the firefighters. So when you know the distances, you can, in absolute terms, say where they are. And the third source is the inertial measurement unit, so-called IMU, which is measuring the acceleration and the orientation of the device. And actually inside this IMU, there are more devices such as compass, and also it can detect the pressure. Pressure is very important because thanks to the pressure, they can define on which floor in a building the firefighter is. So at the end, they take all this information together. They use sophisticated particle filter algorithm to give the commander the final position of the firefighter.
So every firefighter has these different sensors on them. So we have a GNSS sensor, we have this ultra wideband sensor, and we have this IMU sensor, and they're all working together to give us a position. Is this then working as a mesh network between the firefighters?
Yes, yes. So if we take the firefighters as devices, the devices which are on the firefighters as a kind of node, these nodes are communicating, and the project is using Bluetooth long range, the version 5.0, and also LoRa for the communication. So these nodes are communicating between each other. They are passing the information from EGNOS on the corrections of the signal from the service called EDAS, which is the same information that is coming from EGNOS satellite but can be taken from the internet. And they're also using this for the communication with the commander base station. And the Bluetooth is good because it has bigger data bandwidth, but doesn't have is not so cannot reach so far. So LoRa actually can work on long range with lower data bandwidth. So in the device, there is something called Communication Manager, which is checking the availability of the technology and decides how the data will be sent in between the nodes.
I just want to stay with this idea of a mesh network just for a second. I just want to make sure that I've understood it. Does this then mean that if one firefighter all of a sudden has better access to a GNSS signal, that will automatically lift or increase the accuracy of the positioning of every node in the network?
Yes, exactly. So let's imagine at the beginning, all the nodes on the firefighters, they get the position from the GNSS. So when they lose the signal from GNSS, let's imagine they're inside a building, they rely on the information from inertial management unit and ultra-wideband. Precision of these two technologies is getting worse by time. And if one firefighter, for example, gets close to the window and the receiver inside the device catches the signal from Galileo, the margin of confidence of that node is increased, and automatically it sends the information to the other nodes, and the position of the other firefighters is automatically corrected, which is a huge benefit for them.
Yeah, that's really, really smart. So up until now, we've been talking about firefighters indoors, and this is clearly the more complicated scenario. Are we assuming here that they have a really accurate digital map of every building? Or when we implement a solution like this, do we assume that we know nothing about the buildings before the firefighters go in there?
Yes, so the situation can be very different. So the solution also works with presumption that the maps might not be available. Normally, there are only few buildings that have good maps, but the solution is able to put the different base maps to the device. So there can be Google Maps or OpenStreetMaps, actually more layers. So inside OpenStreetMaps, in urban area, bicycle layer is very good for them, for example. But the situation can differ by country. So in Ghent, Belgium, the firefighters which are part of this project, they have 3 people working on digitization of the maps. So in case there are detailed maps in the future, it can be easily imported in the system.
So when we have detailed maps of a building, for example, will this solution, is it smart enough to know that, okay, there's a wall here in the building, this is a door, that kind of thing, and sort of correct itself? So if it's showing that a firefighter has a position inside a wall or inside a locked room or on the other side of a wall, is it smart enough to realize, hey, okay, that's not possible. You can't just go through a wall. Can it use that external information to add corrections to the positioning system?
Yes. So actually, this is what the technical researchers in the project wanted to use, to have the wall as kind of a reference, another reference for the position. And actually, the algorithm worked better with that information. However, not all the time, because the walls can have holes in them during the fire. They can also collapse. And sometimes, in special cases, they can even decide to make a hole in the wall because it is dangerous to go a different way. So in extreme cases, it's not possible to use walls inside building as a reference for the algorithm.
Okay, so we've talked about these two really, really interesting examples. We had the drones that are finding people after natural disasters. And we've just talked about positioning firefighters indoors and all the challenges around that. So quite different sort of use cases. What makes them usable? What makes them exciting solutions? Have they had to completely reinvent the wheel and create new technologies, or are they just pushing together or stringing together known technologies, known hardware, known software in unique ways?
Yes, thank you for the question, because often when I speak about innovation, people imagine that, or the companies imagine that they have to invent really something breakthrough that nobody saw. Actually, the innovation often emerges from the simple merge of different technologies and sensors. So if you look at these projects, the technologies that are combining were there before. It's just that the way it is unique is that they put exactly these technologies and these sensors together to arrive with the final solution. And then also the algorithm is a special thing that they need to also do. And also in case of IOSAT, they had to really fine tune the algorithms for that reckoning when they're measuring how the firefighter walks, because it's very different to normal persons.
Do you find that projects like this often get split up? And so we take one piece, like you were talking about that algorithm for how the firefighter walks. So that's a very specific use case. Do you see projects like this being split up into different sort of technologies? And, okay, let's take that algorithm and apply it to another use case, for example. Or let's take this piece of the positioning system, which is working really well, and apply it somewhere else. Does that ever happen, or do they normally sort of stay clumped together the way they are used in these particular use cases?
What also often happens is that they don't use the technology only for the original intent final product, but they discover a lot of things and develop a lot of, let's say, core technology concepts that they can use in further products that they're doing later on.
If I'm sitting out there and I have this really great idea, which is based off of GNSS, what should I do? Should I come to someone like you and say, hey, look, I've got this great idea. I've got this amazing piece of technology and it's applicable to this particular use case. Do you have any advice for us?
Yeah, sure. So it depends, I would say, if you individual or if you a big company. But to the individuals out there, let's say students or people that don't run necessarily a company, I would say the perfect way how to test the idea is the competitions that we are running. So we are doing different competitions where they can apply with their idea, describe what is the problem they're solving, how they're solving it, what would be the business case, and we evaluate these applications and select the winners. So the competitions that we did in the past, for example, is My Galileo solution, My Galileo drone, and then we have competition for geomatics, competitions for agriculture applications, and we also have special prizes in competition called Galileo Masters, and in future also Copernicus Masters. So I think this is a very good start for individuals and small companies. Then the incubation is also something that is very good. So often if we select, let's say, top 30, we continue with the companies helping them to develop the solution. We train them from the business side and we provide them kind of incubation, even not fully, but we can also, for example, pay them the full incubation, which is very useful for the projects. And if there are bigger companies such as the small, medium enterprises, I believe that they could participate in the Horizon Europe projects where they can read the call for proposal, which will be published very soon, and answer to some of the calls together with their partners.
I just want to clarify, is this only available, this kind of support that you're talking about, is this only available to European citizens based in Europe? Or do I just have to be someone with an idea who's using this kind of technology, who's taking advantage of Galileo?
We are agency of European Union. That means that we mainly focusing on the member states of European Union. So in Horizon 2020, It's usually the companies or organizations from the member states. However, the organizations from third countries can also participate if it's justified that it's necessary for the project.
If I came to you with a project and I said, hey, I've got this project here, I think it's a really good idea, I think it's a novel idea, could you tell me what you're looking for? What would get you excited about my project? What kind of elements would it need to include?
Me personally, I think it is important to have the skill set. So in case it's a small startup, I think it's very important to have people with the right skills in the team. And similarly, in case of bigger project, it is good to have a clear role for each partner and what that partner is bringing to the project. And also that all the gaps that you need in the project to have, that you have the right partners for that. Then the second thing I would mention is to know the state of art. So to know what is the level of technology at the moment and what are the competitors. And third, to be able to explain what is the problem and how to solve the problem.
How important is it for you that I show up with a minimum viable product?
It is only beneficial. So, of course, it depends on the level where you're applying. With you applying just with the idea, it might not be necessary. However, it's always a big plus, even for us or even for investors, if you have the minimum viable product to show.
Lots of people talk about the minimum viable product. Has anyone ever shown up with the minimum viable audience and said, hey, I've got this really great idea and I've got an audience ready to buy it. Will you help me make it a reality?
Yes. So often when the projects apply, they already say which companies or which users would be interested in such a service, or they even provide the letters of interest from different organizations which are highlighting the importance of such a solution for them.
If I'm leading a team of people working on a project, what kind of skills are you looking for in me?
Well, first of all, of course, the leadership skills, the management skills, and then to have the good overview of the market and the technology. I mean, you don't need to know the details because the other people know the details, but you should be aware of the big picture and be able to know where you're going and how you get there.
When you look at successful teams, have they done something like this before? So someone comes to you with a project, with an idea, and they actually get it implemented. Is there some sort of correlation between teams that have been involved in this kind of thing before? Or is it just, can anyone show up and have an equal likelihood of succeeding, whether they have experience doing these kinds of things or not?
Actually, we have a mixture of both. So they are really experienced companies which were in the field for years, and they are able to arrive with new innovative concepts. But then we have also, especially in the smaller competitions, we have very, I would say, motivated teams that have not done something similar in the past, but are really motivated to go ahead and try it and develop the solution. So both is possible, but it is always beneficial if there is somebody in the team which already has experience with similar project. It helps the team a lot.
Thank you very much for your time. Thank you for walking us through those examples. Really appreciate it. Is there anywhere that the listeners can go if they want to learn more, or if they want to reach out to you or to continue this conversation?
Yes, of course. So I can only recommend our website of GSA, where you will find all the opportunities that I mentioned. Also, there described the projects that I mentioned. So I think it's a good start there.
Thanks again, Wojciech. I really appreciate it.
Thank you very much.
So I really hope you enjoyed that episode. I just want to take a couple of minutes here at the end just to highlight a few things for you that I found particularly interesting. So the first one for me was those two projects, those two case studies that we talked about. They were all based on existing technologies, and for me at least, a big part of the innovation there was the combination of the technologies, how they were put together. And I think this is really exciting. This lowers the barrier to entry. This means that if I have a good idea, I don't have to show up and invent cloud computing. I don't have to show up and invent a global navigation satellite system. I don't have to show up and invent the internet. I can take existing tools, existing technologies, and combine them in such a way that I create something new. Or maybe I don't even create something new. Maybe I follow a known recipe. Maybe I use a known combination of these tools and just apply it to a different use case. And if this is innovation, if this is what innovation might look like, then this is good news. This means that we can participate. This means that the biggest barrier to entry is seeing the system, deconstructing the system, understanding the different building blocks and the combinations that we can put these building blocks together in order to surprise and delight the people that we are seeking to serve. But wait, what's that? You have an idea, you can see an opportunity, a unique combination of tools and services which might just solve a problem in a way that is better than the existing state of art. So what's holding you back? Well, if you're anything like me, it's what Steve Pressfield refers to as the resistance. The resistance is that little voice in your head that's designed to keep you safe. Every time you're faced with the decision of, should I try something new, and armed with the knowledge of this might not work, the resistance shows up. And the resistance eagerly manufactures thousands of reasons why you shouldn't try the new thing. It reminds you of all of your past failures. The resistance is designed to protect us from conflict and tension, but it also gets in the way of us doing our best work. I have a couple of thoughts on this, and the first one is that the absence of conflict is not necessarily harmony, it might be apathy. And if the answer to the question is, if this doesn't work, will I get to try it again? Will I get to continue playing the game? If the answer to that question is yes, then the resistance might not be protecting you, and it's probably holding you back. And that's it for another episode of the MapScaping Podcast. Thank you so much for tuning in all the way to the end. It's much appreciated. I just want to remind you that you are more than welcome to reach out to me on social media. I'm most active on Twitter and LinkedIn. Okay, that's it from me. We'll talk again next week. Bye.